Okay, so now we are doing today's code forces contest. So let's start with code forces round 857 it was, right? So now in this you have been given basically t number of test cases, a number n, and then a array containing numbers. So the number can be 1 and 2. What this number represent? Basically what is happening, this is a situation when a person is buying some pigs and keeping them in some boxes, and one represent that you are buying the pig, and two represent that you are calling a doctor. So what doctor is doing, basically to find the gender of the pig, you need a doctor will tell you what is the gender of the pig, right? And the shopkeeper does not know, you don't know, but the doctor knows, and doctor will tell you. Now the thing is key, you're storing these pigs into the boxes. You want to minimize the number of boxes required to store all these pigs. The thing is that box can contain only two pigs. Also the condition that box should not have a pig of same kind, two males, two females. They can have different kinds. Sorry, box cannot have a, a different kinds. One box cannot have one male and one female, basically. Yeah, that's the thing, because box can contain only two elements, right? So that is the thing. So anything greater than two does not make sense in terms of one box, right? So box can contain either two males, or either two male, or two female, or one male, or one female, right? This is the thing, and at last you have to return the total number of yeah, box required. So I know the question problem statement contains so many things, but the biggest and important thing is how the box condition are this, like box can store two elements and two pigs of distinct types. So now the thing is, like doctor, what is the role of doctor? Or doctor is basically telling you the gender of the pig. So let's start with this one. So when you have test case, like first all the three pigs, you don't know the gender of this, because one means you are buying. When you are buying, you don't know the gender. When that you will call doctor, then only you will know the gender. So you have to place this in the one box, and then this also contains why you are not keeping the first two in the same box and not using the why we are not having this key, just place all the two into this one, and then like up till this point time. So I have seen two pigs. Why I'm not keeping those in the same box? Why? Because I don't know what is their kind. Are they male, are they female? So I have to satisfy all the possible scenarios, considering the worst possible scenario that these two are different, like this is male and this is female, because I don't know. So that's why you have to take care of that scenario as well, right? So now you will again, the another pick comes, so you will keep into another thing, another box. In this case, three boxes are required, because you don't have doctor, you never know what is the situation, the kind of this pigs, whether they're male female. So in this case, no pigs is there, so zero pigs, so zero box, just you are calling a doctor, that doesn't make sense. And then in this case, first you will store pig into this one, store three pigs completely independently, because you don't know their types till now. Now the doctor will come. Doctor comes and doctor says that some are K1 type, some are K2 type, some are male, some are female, basically. So the what are the possibilities for three? The possibilities for three is three male plus zero female, right? And two male plus one female. Okay, there are also other possibilities, which is one female, one male plus two female, but that's same. So let's keep it as like the two ways to divide three is 3 comma 0 or 2 comma 1. 3 is of type 1, 0 is of type 2. Type 1, type 2 can be anything, male, female, female, male. Now the thing is, in which scenario you will require maximum number of boxes? In both the scenario, you will require three boxes. Why? Because in this scenario, when there are all three males, so you can store two of them and then one of them. In both the scenario, you will require only two boxes. So now in this case, there are two males, so you will store the two males in this and one male separately. But the thing is, like this is K1 type, two of K1 type, and this is K2 type. In this, all are K1 type, right? K1 type, and this is also K1 type. K1 can be male or female, K2 can be male or female, but K1 and K2 are different. This is the thing. So in all the case scenarios, you will just require two box to store all these three, because considering first you use three box, you bought the three pigs, you bought the three boxes, you put them into this, but now you know that you just need two boxes in all the scenarios, considering the worst also. So two and one is what you need, so you will have one free box. Now one free box can be used to store the next one which is coming up. Now there are no doctor after this, so we don't know like whether this is what's this kind. I don't know, this is of kind K1, this is of kind K2, you can say, or K1. In both the cases you require two, right? And I don't know what is the count for this, right? Like this can be anything, that's what I'm saying. K2, it can be K2 or K1. In both these things, this is this. Now Now let's talk about this. So basically, now let's start talking about logic also. So logic is you need to see all the continuous number of ones, because when you are just buying, 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 you don't know what are you buying, why, whether you are buying male, you are buying female, how you can put this. So you need a different box every time you are buying, right? So you need a different box, you need a different, just placing one into each box, one into each box, and then after some time you consult the doctor. Doctor will tell, okay, these many are male, these many are females, but there is, we don't know what doctor is saying, right? We consider the worst case scenario that n by 2 are male and n by 2 are female. This is the worst case scenario. N by 2 or n by 2 plus 1, depending on n minus n by 2, or basically c minus c1 c by 2, because and like, yeah, you can say anything. Okay, c minus c comma c by 2 comma c minus c by 2. C is the total number of ones which are there, right? Well, the total number of pigs which are there, and then you will say, okay, the box is required to store this is also c by 2 plus 1. Generally, like if the pig is 0, then you don't need any box, otherwise you will require c by 2 plus 1, right? uh yeah, so these are the boxes you can, for now just consider that for worst case scenario you just need c by 2 plus 1 boxes. Okay, in this all is covered, right? In this all is covered, some boxes would go to your your one kind, some boxes would go to your kind two, but you can all place them in these many number of boxes, right? You can just prove this, like example ले लेते हैं. So six, right? And three male or three female, right? This is also there, or let's say four males and two females, right? So yeah, but the what is the this scenario will give you the, like all the scenarios, among all the scenarios, right? Among all the scenarios, some will require, like what are total scenarios first? Let's see. 1 5, 2 4, 3 3, and then they are repeating, so we're not considering that. So this requires how many boxes? Let's see. One for one, or for five it will require three, four boxes are required. One for two, and then two for this kind of four, right? Only three are required. And this three, how many required? Two for this plus two for this, which is equal to four, is this. So maximum you can consider, this, you can just prove this by yourself, that the maximum you will require is four, which is 3 plus 1, which is n by 2 plus 1, c by 2 plus 1. So if c is equal to 6, the maximum number of box you will require is c by 2 plus 1 in all the cases. Now some boxes will be free. You used total c boxes, you used, I think, or not actually C boxes you used, you have another variable to know how many boxes you have used. Okay, TOT, because like every time you are seeing the doctor, let's say now you see the doctor once, before was there also, there was a time when you saw the doctor, like when you, yeah, when you consult the doctor, so doctor told you, and you total number of is not equal to the total number of boxes present there is not equal to the total number of the dogs are which are there, sorry, pigs which are there. It can be less than that if you have consulted doctor previously also, but even if you are consulting the doctor for the first time, for storing all these pics together you will need C boxes. But let's say you consult doctor at this point, so doctor will say for this three you just need two boxes. Okay, now two plus for these four, considering that you do not have saw the doctor till now, so you there are two boxes in use, one box is free, something like this would happen, right? I would say, what is this free, what is this leftover box? Okay, because for this three ones we have already seen that for this three ones what the scenario happens to be, and when you consult the doctor, first you store all the three like as it is, and then you consult the doctor, it becomes either 2 1 or 2 1, yeah, only, and one box becomes free. Now when one box becomes free, it's just free, it's plays as it is, right? So now the situation until this point is 2 1 and one box is free. Now first one comes up and it will take this place. Now all these three will come up and you don't know what is their kind, so you will use a different for them, right? Even you don't know the kind of these all four, you just need know the kind of these two and one, right? So now after this, when you consult the doctor will come up and he will say whether he'll check these and he will free some boxes, and yeah, that's what will happen, and then there will be continuous number of ones. So that's what I'm saying, the total number of is not equal to the total number of, considering this is the total number of, okay, now let's just focus. TOT is the total number of boxes which you have till now. Okay, okay, and then you are doing calculating the leftover boxes. Okay, you use c by 2 plus 1, so leftover is equal to your TOT minus में is required. What is required? Are required equal to c by 2 plus 1. Okay, or maybe you just directly minus that, right? So this is your leftover, whenever you see sum 2, whenever you consult a doctor, you get a new value for the leftovers. That okay, this is the total number of boxes which I have bought for, just to keep up with that I have to store the pigs such that the condition or condition must follow. Why you used all these ones? Why don't you put this into to make this a two? Because you have to keep up with the situation that you don't know their type, and you cannot place blindly that this you don't, if when you don't know their type, right? So that's the thing. TOT, you are buying them kind of blindly, and then you see like okay, when you consult the doctor, then you get to know okay, these many are leftover boxes which I can use, because now I have placed some of the pigs into some other. Oh, that's a lot of logic. Now let's code this. It's actually not that tough question. Somewhat logic, or you will understand that very easily. This is the first problem. We will do this. Int n, c in n, and then just array n. Then you place it, and then you iterate over this. If like the AI is equal to 1, you are buying something, so you will say C plus plus total number of you know the pigs, whatever. Now the thing is, if there are some leftovers, okay, so you will say ki, I'm not buying the new, right? I'm not buying the new. I'm just using my leftover, reducing it by one. Otherwise, I'm buying some new buckets. So TOT buckets plus one, not buckets, just boxes, right? Or yeah. Now else part, when you're consulting a doctor, so you will see how many buckets, how many boxes we actually need. That is, int required is equal to c by 2 plus 1, considering c is not equal to 0, otherwise it would be 1, but for c equal to 0 nothing is needed. 0, and just this, and then this, and this, and this. Yeah. Now now what? Now you say leftover, update your leftover, right? Is equal to total number of boxes which you have buyed and are required, which you actually require, and that's all about it. And you just see out your TOT, what you actually bought, what you needed to bought. So int c starting from 0, TOT is equal to 0, leftover equal to 0. After this, we copy this up, and yeah. So basically, it's that kind of question that for all ones you consider first, and then when you see two, you basically manipulate something. You just what is actually required, what you have taken, what is left over, and yeah, that's kind of question. Now now submit this up. Actually done it actually. Now let's move to the next problem, which is a 13-14 minutes for the first problem. Sorry, B problem. That's fine with it. Let's do a. A was also slightly more kind of like textual problem, but logic is straight one liner. You have been given a basically event, and persons are liking or removing the like. Person cannot dislike. Person can like, and person can remove the like, right? So in the ith second, AI person either like or remove the like, and there is also the like remove the like makes sense only if first you have liked the video, or then you remove the like. If AI is equal to 0, then person put a like. If AI is negative, then the person removed the like, you know, which means that, yeah, minus AI means like if the number is 2, which means second person liked the thing, and if it is minus 2, second person disliked the thing, and you can only dislike after the liking, that's for sure. So 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 you are analyzing this series of event as a time frame. So you want to calculate at particular ith time what is the maximum number of likes which you can have, what's the minimum number of likes that you can have. So now let's move towards the test cases. We'll discuss this and then code. Not much of a do, but yeah. So basically you can they are saying that for this 1 2 minus 2 you can have any permutation. 1 minus 2 2, no, that doesn't make sense. Minus 2 cannot come before 2. The situations are possible are this: 2 1 and minus 2, and the given one, which is this, and maybe there are some more, but you have to consider p1 one permutation and p2 one permutation, such that p1 is such a permutation where at every ith second you are having maximum number of likes that you can have. For second you can have only one like, that's maximum for the first second. For 2 second there are actually two positives, so you can have two likes, but then the only remaining is negative, so you will likes will decrease and it will become one. Now for first second the minimum number of likes which you can have is just one, because you cannot say that first I removed the like, because for removing the like you should have to like the video. So let's say this is the p1 scenario. Let me tell you what is the p1 scenario. P1 scenario can be 1 2 minus 2, or it can be 2 1 minus 2. Both will correspond to p1. P2 scenario would be 2 minus 2 and 1. I don't think another possible scenario for this one. You like the video, immediately dislike it to make it 0, and then you don't you cannot do anything. You have to like the next video, which is 1, because one person is liking it basically. Yeah. Now this is the thing which I'm talking about. One can not come after minus 1. So 1 and then minus 1, right? So p1 permutation in this is simple. Corresponding to max is 1 comma minus 1 permutation. Like, yeah, the permutation is not this. This is the max at ith moment kind of thing. These are the possible permutations. Okay? So this is the possible permutation p1, and this is mn minimum kind of thing, and these are the possible permutations, right? In this case, like if I do 1 comma 0, this is the actual answer. This is, yeah, this is for max and min. The answer is same in this, because the only one way to like to happen these two things is the first one and then minus one. There is no other way, right? So answer for this is constant. Now in this case, let's see what are the permutations which will give you maximum. If you do 1 2 3 4 and then you do minus 1 and minus 2, this is the maximum number of likes which you have at the ith moment. First one, first like, 2 likes, 3 likes, 4 likes, and then 1 like reduce, you get again 3 likes, again 1 like reduce, you get 2 likes, right? So that is the thing. And obviously there are more possible permutations for this one, like like you just like you start from 3, then 4, then 2, then 1, and then minus 1 minus 2, and minus 2 minus 1, whatever. Just so many permutations for this one. And what is the permutation for minimum one? For minimum one, it would be something like first you just liked it and immediately disliked it, because that's what you can do. You cannot dislike it then like it. So basically you cannot remove the like. Basically you would like to have that, but that is not in your hand. You first have to like it, then you remove the like, then you like, and then you remove the like. And then you cannot do something because you have two more likes, then you have to like it with 3 and 4, and that's about it. So this is 1 0. uh, sorry, the mn corresponds to what's happening, 1 0 1 0 1 2. This is the thing, and so on. Not doing more test cases. Let's just move towards this one. N is there, an is fine. Remove this part. I need to have number of positive and negative. So the logic for this one now, many people say I don't tell logic. So the logic for this one is positive, negative. You have to calculate the number of positive elements and negative elements, and then for max kind of permutation, you first place all the positive, then place all the negative. For min kind of permutation, you place negative, you place positive, and corresponding negative, right? Corresponding negative. Then you do it like till you have positive negative pairs. Then if you have some positive remaining, then you will put positive remaining positive. If you don't have, then don't put. This is the three liner logic, and let's code it in 4 lines. So int pos is equal to 0 and g is equal to 0 if a of I is greater than 0. I would say pos plus plus, else I would say any g plus plus, right? So positive element, negative elements, then you have iteration, not iteration, just yeah, printing the answer. Plus 1, and then for all the negative ones, negative I plus plus, I would say C out P minus 1. This is the point where I would be leaving over. So let's say four positives are there. So one, two, three, four. Then one negative comes up. So I would start from which point? I would start from the 3. Okay, I would start from 3. So P minus 1 minus I, which is 0 first. So 3, 2, and so on, it will go on. This is for positives and this is for negative, and I is equal to negative special, not much special, but yeah, 2 into negative I plus plus, C out basically 1 and then 0. Positive negative positive negative positive, 1 0 1 0 1 0, right? And then remaining positive. How you will get remaining positive? That's not much tricky. You can say n total minus 2 into negative, which you have already put, and now the remaining part is I plus 1 and L. And yeah, that's straightforward 4 line code, and test it over the given input. Not end L, but yeah. Over here also, P is for sure not defined, POS is defined, end L is not there. K and L is not there. Between positive negative, you want and L2. Now we can sum this up. 5 4 3 and 1 2 3. We'll do C and D in the next one. Actually, I would say C and D problem collectively have the difficulty level of A and B collectively, because C was very easier than B and A also. But yeah, again, A is accepted. That's about it.